industry at present relies on increased productivity and uniform quality of end products. To ensure these requirements, special purpose machines have been designed in order to perform predetermined functions and automate the manufacturing. Automation of industrial production involves introduction of mechanical, electronic and computer-based systems to assist production and control of parts. Transfer lines, numerically controlled machines and feedback control systems are the examples of automation. Automation can be classified into two types. One is fixed automation and flexible automation. Fixed automation is also known as hard automation. In fixed automation, we have specialized machines to assist the production, but it has a disadvantage of inflexibility, that the specialized machines which have been designed for producing a particular product has to be modified or changed and hardware retooled to manufacture the next generation of models. This change of specialized machines design will involve a lot of expenditure. So to avoid this expenditure, flexible automation has been envisaged. In flexible automation, we are going to use manipulators which can be used for performing different tasks. Programmable manipulators are being used for spot welding, arc welding and assembly tasks. This flexibility has been introduced by the programmable manipulators will be forming a soft automation, and this soft automation, the mechanical manipulators can be reprogrammed using computer control in order to do different tasks. Hence, the robots which are used for performing different tasks has been identified with the soft automation, and robots will be used for spot welding, arc welding, spray painting, assembly and inspection tasks. The study of robotics concerns itself with the desire to synthesize some aspects of human functions by the use of mechanisms, sensors, actuators and computers. Now we'll see the definition of robot. It is a reprogrammable, multifunctional manipulator designed to move materials, parts, tools or specialized devices through programmed motions for the performance of a variety of tasks. This is the definition as per Robot Institute of America. An industrial robot is a general purpose computer controlled manipulator consisting of several rigid links connected in series by revolute or prismatic joints. Now we talk about an industrial robot. What we are going to study in this lesson is an industrial robot, which is also called a robotic manipulator or a robotarm. Now in this robotarm, we are going to have the links serially connected to form an open chain by means of flexible joints. The joints used in robotic arm are revolute or prismatic joints, and each joint will be allowing one independent motion. The revolute joint will be allowing relative rotation between the links, and prismatic joint allows relative translation between the links. In robotics, we are going to number our joints and links starting from the base. The base is considered to be zeroth link. Unlike in plane motion mechanisms, we are going to number the first link itself as number 1. But this is the major difference in the study of robotics. In robotics, the base link is the zeroth link, and from base all the links will be numbered. And also the joints will be forming between the two links. The first joint will be found between the base zeroth link and the link 1, and these joints will be allowing the motion. Since each joint is allowed to have one independent motion, the number of joints will be defining the number of degrees of freedom. If you see the definition of number of degrees of freedom, the number of degrees of freedom of a manipulator is a independent number of joint variables to locate the parts of the manipulator. Hence, the number of joints or number of axes will also indirectly express the number of degrees of freedom available in a manipulator. As we had seen earlier, a robot arm will be comprising of links connected in series and by flexible joints to form an open chain. In this, each link is connected to at most two other so that no closed loop is formed. And now we are trying to show a robotic arm, which is an articulated robot arm. Why we have chosen articulated robot arm to introduce this industrial manipulator? Because it is similar to a human arm. It can be modeled as a chain of rigid links interconnected by flexible joints. Links correspond to such features of human arm: waist, upper arm, forearm, while the joints are shoulder, elbow, and wrist joints. At the end of the wrist, it is connected to an end effector, which is also called gripper or hand, or sometimes a tool is held in the end effector. Each joint represents an interconnection between links, and each joint is going to allow one independent motion. Hence, the number of joints or the number of axes representing joints will be giving us the degrees of freedom of the manipulator. Number of degrees of freedom of a manipulator is the number of independent position variables required to locate the parts of the manipulator. In order to position a rigid object and orient on the object in three-dimensional space, we require 6 degrees of freedom. 3 degrees of freedom are required for positioning, and 3 degrees of freedom are required for orientation. Well, some robotic arms will have less than 6 degrees of freedom, or maybe having more than 6 degrees of freedom. If a robot arm is going to have less than 4 degrees of freedom, some of the orientations cannot be achieved by the robot arm, since 6 degrees of freedom required to orient the position and orient the object in three-dimensional space. If robot arm is having more than 6 degrees of freedom, then it is going to have redundant degrees of freedom. These redundant degrees of freedom are required in order to avoid obstacles or avoid undesirable geometric configurations. Having seen an articulated robot arm, now we are going to classify the robot arms. Classification of robot arms is first based on geometry or kinematic structure. Kinematic structure classification is based on the first 3 joints, and these first 3 joints whose axes are called major axes. These major axes are normally used to position an object in space. And this classification, we have got a choice of 2 types of joints, revolute and prismatic joints, which can be chosen to form the first 3 major axes. So choosing the one joint from revolute or prismatic, the 3 minor axes will be filled up. Basing on this choice, we have got different classifications, that is Cartesian configuration, cylindrical configuration robot, spherical configuration or polar configuration, and articulated or joint arm configuration, and finally we have SCARA configuration.